Somewhere out past the orbit of Pluto, past every planet, past every place a human being has ever physically traveled, there is a machine the size of a small car moving through the dark at 38,000 miles an hour. It has been out there for almost 50 years. And for a handful of days, NASA had no idea what was happening to it. Not the data looked strange. Not the signal was weak. Silence. A machine humanity has been talking to almost every single day since 1977 simply stopped answering. This isn't a hypothetical and it isn't science fiction. It happened. And what caused it, what the spacecraft did to itself without asking permission, and what a small team of engineers had to do to talk it back to life from a distance where a single message takes nearly a full day just to arrive, is one of the strangest rescue stories in the history of space exploration. Most people never heard about it because it didn't make the kind of headlines an actual planetary disaster would. But if you understand what almost happened, you'll understand something most people don't. This spacecraft is now living on borrowed time, and the day it went silent in 2024 was not a fluke. It was a preview. By the end of this video, you'll understand exactly what happened, minute by minute, why it very nearly became permanent, why the fix was more delicate than almost anyone realizes, and why the exact same vulnerability that caused this is only getting worse as the years go on. I'm Jameson Evans, and this is the story of the day we lost Voyager 1, the 2.5 weeks that decided whether we'd ever hear from it again, and what it means for the years the spacecraft has left. Subscribe now because we're going deep into this one, and it gets stranger the further in you go. To understand why losing contact with Voyager 1 is such a big deal, you have to understand what this spacecraft actually is, and how absurd it is that we're still talking to it at all. Voyager 1 launched on September 5, 1977, riding a Titan Centaur rocket out of Kennedy Space Center. Its job on paper was modest. Fly past Jupiter, fly past Saturn, take some photographs, gather some measurements, and then drift quietly into retirement. NASA's own planning documents expected the mission to wind down somewhere in the early 1980s. 4 years, maybe 5, and then silence, a successful, tidy little postcard mission from the outer solar system. Instead, Voyager 1 kept going. It flew past Jupiter in 1979, sending back the first close-up images of that planet's cloud bands and its moons that human eyes had ever seen. It flew past Saturn in 1980, using the planet's gravity like a slingshot to add speed and bend its trajectory outward. By the end of the 1980s, it had already traveled farther from Earth than any object humans had ever built, and it was still transmitting. Then, in August of 2012, 35 years after launch, it crossed the heliopause. That's the boundary where the solar wind, the constant stream of charged particles pouring off the sun, finally runs out of pressure and gets stopped by the pressure of interstellar space pushing back from the other side. Cross that line, and you're no longer inside the bubble that contains our entire solar system. You're in the space between stars. Voyager 1 became the first human-made object in history to make that crossing while still alive and transmitting. It is, right now, the only operating spacecraft humanity has ever placed outside that protective bubble. It's been running for nearly 5 decades on hardware that predates the personal computer, using a command language and operating philosophy from an era when computer usually meant a room full of humans doing arithmetic. And it's doing all of this on a power supply that never gets refueled and never stops shrinking. Every single year it has a little less electricity than the year before. Which brings us to why, on one ordinary Tuesday in October, everything nearly stopped for good. Here's the part of this story that makes it so unusual, and honestly so unsettling if you sit with it. Nobody did anything wrong. There was no collision, no dramatic external event, no obvious single point of failure anyone could point to afterward and say, "There, that's the mistake." What triggered the entire crisis was the spacecraft trying to protect itself, using logic baked into it decades before anyone currently working the mission was hired. Think about Voyager 1's onboard computer the way you'd think about a circuit breaker in your house. If something draws more power than the system is rated to handle safely, a protective system steps in and starts shutting things down automatically. No phone call, no permission slip, no waiting for a human to weigh in. For days, the team didn't know for certain whether Voyager 1 was transmitting anything intelligible at all. Every hypothesis, every diagnostic command, every guess about what might have happened had to travel across a one-way delay of roughly 22.5 hours. Send an instruction Monday morning, and you won't know whether it even arrived until Tuesday morning. Then you wait again for whatever response comes back, if anything comes back. Meaning a single question and answer exchange costs the better part of 2 full days before you know if you guessed right. There is no repair crew you can dispatch. There's no reset button anyone can walk over and press. The only tool available is a radio signal traveling at the speed of light, and even light takes its time across 15 billion miles of empty space. Every step of this process had to be taken with the knowledge that a wrong command, sent confidently across that distance, could make things worse in ways that wouldn't even be visible for another full day. Engineers worked through the possibilities systematically. Had the fault cascaded into something bigger than a single transmitter swap? Was the spacecraft simply idling on its backup systems exactly as designed, patiently waiting for new instructions that hadn't arrived yet? Or was this the beginning of something with no fix at all, the kind of failure that, on a machine this old, this far away, and this thin on power, might simply not be recoverable? Eventually, using the most sensitive listening equipment the Deep Space Network has, engineers managed to detect something. A faint carrier signal on the old S-band frequency. Not full data yet, just a heartbeat. Confirmation that the spacecraft was still alive, and still, in its own automated way, following the programming it had been given decades earlier. From there, over roughly 2.5 more weeks, the team carefully worked out how to command the spacecraft to bring its main transmitter back online without triggering the same protective response all over again. And it worked. Voyager 1 came back. The X-band signal returned. Full science data resumed flowing across 15 billion miles, the same way it had for almost 50 years. A machine older than most of the people currently keeping it alive had protected itself exactly the way it was designed to, and then let itself be carefully, patiently talked back online by a small team using instructions built on top of a design philosophy from before color televisions were common in American homes. Here's why this story isn't just a strange footnote from a couple of years ago. It's a preview of exactly what's coming, and the reason is simple physics that nobody can negotiate with. Voyager 1's power doesn't recover. It never has, and it never will. The spacecraft draws its electricity from 3 radioisotope thermoelectric generators, which convert the heat given off by decaying plutonium-238 into usable power. At launch, those 3 generators produced roughly 470 watts combined. Today, after nearly 50 years of steady radioactive decay, that number has fallen to somewhere in the neighborhood of 250 watts, and it keeps dropping by a few watts more every single year permanently with no way to refuel it or slow it down. That decline is exactly why NASA has been forced into harder and harder trade-offs with each passing year. Of the 10 scientific instruments Voyager 1 originally carried, most have already been permanently switched off. Not because they broke, but because there simply isn't enough electricity left to run everything at once. Every time an instrument gets shut down, it's a decision made carefully, because there's no way to turn it back on once its power has been reassigned elsewhere. The same math that caused the October 2024 fault protection event only gets tighter from here. Less power available means a smaller safety margin, which means the same kind of routine command that triggered this whole episode becomes more likely, not less, to push the spacecraft into another automated shutdown. Engineers have been testing an experimental power reconfiguration procedure, nicknamed internally as the Big Bang, designed to squeeze extra usable electricity out of systems that are currently running less efficiently than they could be. Tellingly, they're testing it first on Voyager 1's twin, Voyager 2, rather than on Voyager 1 directly. That's not because Voyager 1 matters less. It's because a mistake during a procedure like this, on a spacecraft with no backup plan and a communication delay measured in the better part of a full day, could end the mission instantly with no chance to try again. And there's a very specific, very real deadline already sitting on the calendar. Later this year, Voyager 1 is projected to cross a distance from Earth where a signal traveling at the speed of light takes a full 24 hours to make the trip one way. 24 hours just to say hello. Another 24 hours to hear anything back. No human-made object has ever been that far from home while still alive and still transmitting. When Voyager 1 crosses that line, it will do so carrying a power system that's smaller than it's ever been, running instruments that are fewer than they've ever been, watched over by a fault protection system that has already shown it's willing to make dramatic, autonomous decisions with almost no warning. Every one of these systems, the shrinking power budget, the autonomous fault protection, the 50-year-old hardware, is the exact same set of systems that briefly went dark in October 2024. That incident wasn't a one-time scare that's now safely behind us. It was a preview of the kind of event this mission is going to keep running into closer together with less margin for error, for as long as the spacecraft keeps flying. There's something worth sitting with here, and it's bigger than a story about a radio transmitter. For a few days in October 2024, humanity's only physical presence in interstellar space went dark. Not because it failed, but because it did precisely what it was built to do, using judgment written into it half a century ago by engineers trying to imagine a future they knew they wouldn't personally see. And then, using nothing but patience, faint radio waves, and almost 50 years of accumulated institutional memory, a small team on the ground carefully talked it back to life across a gap of 15 billion miles. Bolted to the outside of that same spacecraft, riding along through all of this, is the golden record. A message intended for whoever or whatever might one day find it drifting through the dark long after Earth itself has changed beyond recognition. Greetings in dozens of languages. The sound of rain. The sound of human laughter. For a few days in 2024, the machine carrying that message went silent. And then, against fairly serious odds, it didn't. At some point in the years ahead, an event like this one won't have a fix. The power will simply fall below what's needed to keep even the most essential systems running, and the silence, when it comes, will be permanent. Nobody knows the exact date. What we do know is that every time something like October 2024 happens between now and then, it will be a smaller team with less power to work with, sending a message across an even greater distance, and waiting an even longer day to find out if anyone's listening back. If you want to understand what happens the next time Voyager 1 goes quiet, because on the current trajectory, there will very likely be a next time, subscribe and turn on notifications. Drop a comment with what part of this surprised you the most, and share this with someone who'd want to know that we very nearly lost contact with the outer edge of human reach and got it back, at least for now.